All right, hello everyone, and welcome to the 11th challenge of Damn Vulnerable DeFi. This one is called Backdoor, so let's go ahead and have a look in it. To incentivize the creation of more secure wallets in their team, someone has deployed a registry of Gnosis Safe wallets. When someone in the team deploys and registers a wallet, they will earn 10 DVT tokens. To make sure everything is safe and sound, the register tightly integrates with the legitimate Gnosis Safe proxy factory and has some additional safety checks. Currently, there are 4 people registered as beneficiaries: Alice, Bob, Charlie, and David. The registry has 40 DVT tokens in balance to be distributed among them. Your goal is to take all funds from the registry in a single transaction. So this is a really tough challenge. It took a little bit for me to get through, and it introduced a lot of different concepts that we're going to have to cover today, including delegate calls, proxies, and some other fun stuff as well. So let's go ahead and have a look at the challenge contract itself. So we have a contract here where there's some constants here that they've set: the master copy, the wallet factory, and the token. We can see that there is a beneficiaries mapping between an address and a bool, and as well as the wallets. We can see that the master copy address, make sure it's not the address 0. It sets the token and adds the initial beneficiaries that are created with the contract deployment. There's an add beneficiaries, which is only owner, remove beneficiary, which is private, and we can see there's a proxy created function here, which is pretty much the main functionality of the contract. So this function is executed when a user creates a Gnosis Safe wallet via Gnosis Safe proxy factory, create proxy with callback, setting the registry's address as the callback. So it looks like once a Gnosis wallet, whatever that is created, it's going to call back here, and it provides some values, some initializer, and some other things. So say someone creates a Gnosis wallet, it verifies that the balance of this address is greater than the token payment, which is going to be 10 DVT, because every time it happens, there's going to be 10 DVT. The wallet address is going to be the proxy, ensures that the factory and the master copy match. Ensure that the initial call data was called to Gnosis Safe setup. So that's what the Gnosis Safe, that's the function selector that was called. Ensure that the wallet initialization is expected. So verifies that the threshold is the max threshold. So that is the minimum amount of signatures that need to happen for anything to occur. Again, I'll go into this with the Gnosis wallet. And the owners is going to be the maximum amount of owners. Now, this is going to be 1 and 1, so you can only have one owner. Then it's going to get that owner and verify that that owner is a beneficiary. Then it's going to remove the beneficiary, add the wallet to this wallet registry contract, and then transfer the 10 DVT tokens that was the incentive. So let's go ahead and quickly cover what is a Gnosis Safe wallet. Now, the best way to describe this again is going to be you should go ahead and have a look at Gnosis Safe and what they do and what it is. I'm going to give a bit of a basic explanation, but definitely go in and have a little bit of a deeper look. My understanding of what a Gnosis Safe wallet is, it's a way to have multi-signature wallets and kind of wallets that can do really cool things within the crypto space. It's kind of like an enhanced Ethereum wallet. More or less, it's essentially a smart contract that's living in the EVM. But say you wanted to spend some funds from your wallet. You can require, you could have multiple owners of this wallet, so different addresses can own this wallet, and you can say that 2 out of 3 owners need to have a signature or sign this before a transaction is submitted. You can have modules, which is what we're going to look into, on this kind of smart contract wallet that can do automated things and really enhance what the Gnosis Safe wallet can do. So what this means is we need to look into Gnosis Safe and how it works to go ahead and exploit this. So the first thing I also want to do is have a look at the setup here. So it's not too long, but it's pretty straightforward. We can see that it gets these 4 addresses: the deployer, Alice, Bob, Charlie, David, and the attacker. It deploys a master copy, a wallet factory, and the token. It then deploys the registry, adds all the users to the registry as beneficiaries, and then transfers the 40 DBT to the token. So how do we exploit this? The second kind of concept that we need to cover is proxy contracts. So within how Gnosis proxy contracts work is that you have a Gnosis factory contract, and this factory contract is its job is to deploy new contracts that are Gnosis Safe wallets. Now, how do you do this without storing the Gnosis Safe wallet contract data itself? And you use what's called a proxy. So what proxies do is they actually allow you to point to a different version of the contract while still maintaining your state. And so these allow things like upgradable contracts, but in this case, it allows a contract that is known to be safe and secure to be the logic handler for your personal wallet. So the way it works is you'll deploy the factory, and you'll deploy a single version of the wallet. Now, the reason that you want to do that is it becomes what's called a singleton. And the factory will deploy a proxy, which any call to that proxy will be delegated to that master copy. So you can think of it like you have your own contract that has nothing in it, has no logic, but anytime logic is called, or anytime this smart contract is called, it offloads the logic part to the singleton contract. Now, what this means is because it's a delegate call, all the state and context of the proxy contract is going to be maintained. So it's almost like the proxy contract is calling a function of itself, but the logic is located somewhere else. That is what a delegate call is. And so what this means is you don't change anything around the state or the variables on that master contract. That master contract is only to store the logic of how to do these operations. The proxy itself will maintain the state. So, the balance, the signatures, the threshold, all this stuff is going to be maintained in the proxy contract. And I'm going to show you what this will look like and how this works. So let's go ahead and take a look on how this master wallet works. So we have this Gnosis Safe proxy factory. Let's go ahead and actually look in our node modules to see what this looks like. So we have this Gnosis PM contracts. We can see there's the Gnosis Safe. So this Gnosis Safe is what's going to be deployed as the singleton. This is going to be deployed that has all the logic in it. So you can see this is all here. And you're not actually meant to deploy this directly. You can see in the constructor, where are you, constructor? By setting the threshold, it's not possible to call setup anymore. So we create a safe with 0 owners and a threshold of 1. Therefore, it is an unusable safe. No one can interact with it, and it's perfect for a singleton. The way that you do set it up is through this setup function here. So you have the singleton that, again, offloads all the logic to here. And so when you want to set up the singleton, set up the proxy, you call the setup function here, which is going to go ahead and do all the setup that require, like, all the settings that you want to provide, like the threshold, the owners, some callback data, and some other stuff as well. Cool. Okay, so how do we do this? Let's go again and have a look at how this works. How do we deploy a new Gnosis Safe using the proxy factory? So again, let's have a look at the contract here. There should be proxies, and we can see that there's the Gnosis Safe proxy. So this is what will actually be deployed. Now it's very, very small, and all it has is a constructor, which has the address of the singleton, which is going to be our Gnosis Safe master copy, and then a fallback function, which forwards all these transactions and returns all the received return data. So every single thing that we call this contract with will be forwarded on again with that logic using a delegate call. Okay, so let's have a look at the proxy factory itself and see how this works. We have a few things. We have create proxy as a function, proxy runtime code, proxy creation code, deploy proxy with nonce, create proxy with nonce. So we can see that this one is actually public, so we could use this. There's create proxy with callback. Now, this is probably the one that we want to be interested in because within the wallet registry, it again requires that the function executed when the user creates a Gnosis Safe wallet via Gnosis Safe proxy factory, create proxy with fallbacks. Let's see how this works. So we need to provide the singleton address, the initializer, which is the payload, which will be sent to the new proxy contract. So essentially, what data do you want to send to the proxy contract when it's done? So this is ABI encoded data. What we want to call is the setup function on the proxy, right? Which is again on the logic with all this data. So we're going to call the initializer and we're going to call it with setup, you know, the address of the owners, the threshold, the two. So this is how we're going to create a new wallet. The salt nonce is just a random number. And then the callback is going to be what is going to be called back once this Gnosis Safe wallet is created. In this case, we want it to be this proxy created function here on the wallet registry address. We need to keep that in mind. So it's going to go ahead and do all this setup here. And that's fantastic to do, and that's great. But where's our exploit? How do we break this? What's the trick here? Because obviously there's some kind of trick here. And the reason that we can kind of break into this, even still, right? Without an exploit, we can create a Gnosis Safe wallet on behalf of Alice, for example. So I'm going to deploy a contract with a singleton. We can create an initializer that's going to set up this Gnosis Safe to have an owner of, say, Alice or David or Bob or any of those beneficiaries with a threshold of 1 and meet all the requirements of the wallet registry. However, the problem is once we deploy it, they will get that 10 DVT. However, we won't have access to the 10 DVT. And one of the requirements for this challenge is to ensure that the balance of the attacker address is the amount of tokens distributed. So we need to get control of this 40 DVT. So how do we exploit this? Where is it? Let's take a look at the Gnosis Safe setup. There's a lot of things here, but essentially, what happens is there's these things called modules within Gnosis. And I'm not fully understanding of how they work and what they are, but essentially they're ways that you can, add functionality to your Gnosis Safe by integrating with other smart contracts again. So let's have a look at how this setup function works. Again, it sets the owners to what you want it to be within the threshold. And then there's this to and data function. So if we have a look at the parameter definitions here, we have contract address for the optional delegate call and data payload for the optional delegate call. And this is called within this setup modules function. So if we have a look at setup modules, we can see that this is under this module manager sol. And this will essentially call execute on, again, the data that we have required, that we've passed in. It's a delegate call again, so it's called within the proxy contract, right? So it's all this logic offloaded, still delegate called, right? So this is still within the proxy contract, which is the thing that is essentially our wallet. We go to execute, and it's going to go ahead and run a delegate call on this. So this is where the exploit kind of comes in and where we can almost install a backdoor. The way that this works, there's two ways you can go about this. Within a Gnosis Safe, you can run what's called exec transaction from a module. Forget what the function's called. Let me see. Maybe it's not here, but there's a way that you can execute a transaction from a setup module that doesn't require any signatures. So that means that if the module wants to send a transaction, then it can go ahead and do it without any signatures. Now, this isn't a bug. This is actually a feature because it allows more functionality and more flexibility with the modules that you're using. You just need to make sure that the modules you're using are safe and secure. The issue is, usually if you want to add a new module, you have to do it and have everyone sign the contract, or all the signatures and the threshold has to be met before a new module is able to be added to the Gnosis Safe. However, in the initial setup, that isn't required because you're already setting up everything, right? So when you add the module on the initial setup, then you can just add whatever you want. So this really gives a whole lot of power to the deployer. And there's an article on OpenZeppelin that really goes deep into how this works. And this is kind of the basis of this attack. However, what we're going to do is not execute transaction with a module. Just during the setup, we're going to set up everything that we need to do to win this this challenge. Okay, so now we've kind of got an idea of how we're going to do this, right? So think of it like this. We essentially need to deploy a malicious contract that will act as a module. We're going to generate the ABI call to call setup token, which is going to be in our custom module. Custom module. Then we're going to call the proxy contract, the proxy factory, with all this custom data, and it should just all go through. And we're going to do this 4 times in a row to make sure that we get all the beneficiaries. So let's go ahead and go through the contract that we're going to deploy. We're going to go ahead and create a new contract, and it's going to be called attack backdoor.sol. Let's take a look at this. So again, within the constructor, we're just storing all the relevant addresses that we may need to access. And we have this function here called setup token. Now, setup token is going to be called during the Gnosis Safe initiation. So Gnosis Safe, the proxy contract, is going to delegate call this contract here and run this code here. And what this will do is it will go to the token address, which is the DVT token, and approve the attacker address for 10 Ether. And that's the amount that is, that 10 DVT amount that's going to be given to each Gnosis wallet safe that's been set up. And what that means is because this is a delegate call, when the proxy calls this contract, it's called in the context of the proxy. Therefore, this is going to be called from the proxy, and the token address essentially is approving the attacker to spend 10 Ether on their behalf. All right, hope that makes sense. Now, what we're actually going to do here is the attacker is going to be this contract address, like this legit contract address, such that we can do this all in one transaction. And then we have our exploit function here. So the exploit function is the main thing that we're going to call. So once we deploy this function, we first need to create a dynamically sized array to meet the signature requirements. As I explained in the last video, you need to make sure that your function selector has the exact same arguments. And so a dynamic array and a constant size array are different argument types. Therefore, we need to make sure that we're doing this as in a dynamic array. So then we create the ABI call for the proxy. So if we go to our Gnosis Safe proxy, Gnosis Safe proxy factory, which I think I may have lost. Let me go back here. Create proxy with callback. So we're going to call it with the singleton. So the singleton is going to be the deployed address, and we can get that because that's done in the initial setup up here. You can see that that's going to be the master copy here. Going back to the factory, we need the initializer. So the initializer is going to be the ABI data that we're creating in the attack backdoor. So this is the ABI here, and this is what we want to call on the Gnosis Safe proxy, which is going to call Gnosis Safe delegately, and it's going to run, where is setup? Where are you? Here we go. It's going to run setup here, and this is what we're encoding here. So you can see here, here's set up with all the relevant types, and we can kind of go through them, right? So we have initially the signature string, so that's going to be this, and then all our parameters we want to pass in. So the address is firstly the owner. Who is the owner? We're going to pass in the victim. And the victim is going to be, this is a big for loop of all the 4 owners or beneficiaries of the contract that we're creating. The next thing is we want to create the threshold, which is going to be 1. So again, meeting the requirements of the wallet registry, which requires that the max threshold and max owners are both 1 and 1. Moving along, we can see the next one is going to be the address. So this is the to address. So this is what modules do you want to set up? We're going to pass in the address of this. We want this module to be set up. And then this is the setup data. Now, setup data is actually going to be called from our code in JavaScript. And I'll show you that when we get there. But this is essentially going to be the ABI data for calling the setup token function here. Then we have some other things such as, what is the next ones? So within Gnosis Safe, fallback handler, payment token, payment receiver, all this stuff we don't need to worry about. We can just set them all to 0. So now that we've encoded that, we then want to call Gnosis Safe proxy factory, create a proxy with callback. And then we can go to the proxy factory. And these are the 4 requirements. We need the singleton, the initializer data, which is what we just created, a random salt nonce, and then the callback address. So this is going to be the master copy, the init gnosis, which is this ABI here, a random salt, and then the wallet registry itself, which is going to receive the callback once the proxy is created. Then once the proxy is created, again, it's going to go through all this, approve the 10 tokens because it's going to approve it here on using a delegate call. And then once this is created, we can just go ahead and transfer from the new proxy to the owner, which is going to be the attacker here. And we're going to transfer 10 ether, or 10 tokens essentially. And we just repeat that 4 times. So let's go ahead and have a look at our actual exploit code. So the first thing we're going to do is connect to all the contracts as the attacker. Token, factory, master copy, and wallet registry. We are going to create a helper function so we can print out the token balance of a particular address. And we're going to just check the address of the attacker and verify that we have 0 tokens at the start. The next thing that we need to do is deploy our attacking contract. So this is going to be what we just deployed with all the relevant addresses that we need. So this is going to be the owner, the factory address, and all this kind of stuff. And let's print out the data for that. The next thing that we're going to do is calculate the ABI or determine the ABI for the setup token. So remember, the ABI, which is required to set up the safe, contains another ABI, which is in the data here, which is the module setup ABI. So we're going to go ahead and call setup token with this address and this address. It's going to have the data here, which is going to be the attacker token address. So what if we go to our attack backdoor, so you can see this is the token address that we're approving for and who we're approving it to. And in this case, we want to approve it for the attack module. And the attack module is actually the contract that we've just deployed. So we're approving the contract to spend the Gnosis Safe's funds. Then we go ahead and do this all in one transaction. So we go ahead and run attack module.exploit with the users and the setup data. So the users is the list of users or list of addresses that we're going to do this for. So there's 4 of them. And then the setup data is what we just set up over here. Then once we've done, we can go ahead and check the token balance of the attacker and verify that it is 40. So again, kind of running through this, attack module exploit, we're going to go into our attack backdoor contract. This is going to go ahead and go through each individual user, create a new array, including that user, create the ABI, which contains this ABI, which is the setup data for here, to set up the Gnosis Safe, call the Gnosis Safe proxy factory with the ABI of initting Gnosis with the master copy, the salt, and the wallet registry, which is then gets the callback. Once it's all set up, the wallet registry gets the callback and runs through here, and this is all good. And then we just transfer, because the module has been set up and we've been approved to spend 10 Ether, we send it back to our address, which is set as the owner. So let's go ahead and run this and see if this is all working. So we're going to go ahead and yarn run backdoor. And we can see that it works. So you can see that we initially started with a token balance of 0. We deployed our attack contract at this address, and then the token balance of the attacker afterwards is then 40 DBT. I hope you learned something today. Again, this was a very difficult one. We only have one challenge left, which is the Climber Challenge, which I find really, really interesting and took me a little while to do. But I will be back very soon, and I'll be posting that one. So again, hope you learned something, and I'll catch you in the next one. See you.